Hi everybody, today I just wanted to go through the key for the Unit 7 practice number 3. Sometimes just looking at a key is not very helpful, so I want to make sure that you understand what's going on here. So let's take a look. It's important that you try some of these on your own, but if you are stuck, we'll work on it together. So first of all, it wants us to figure out which of these could represent the graph that's here. You could type them into y equals, but let's think about some of the characteristics that we've learned. So remember, this number right here is always your y-intercept. So if we look, our y-intercept's positive. So it can't be -5 and it can't be -2. So that allows me to rule those two out. The other thing to look at is the first number. Remember, if your first coefficient, that number in front of x squared, is positive, it's going to open up like a smile. If it's negative, like this one, it's going to open down like a frown. So since this opens down, concave down, it's going to be choice 3. And again, the -2x squared means that it's concave down, and then the +11 is the y-intercept. And it's got to be positive, otherwise it would be hitting down here. All right, the quadratic function f of x has selected values shown in the table. It says, what are the coordinates of the turning point? Remember, when you're looking at a graph, if you have this U shape, wow, it's a little, not very smooth, but that's okay. Everything on each side matches up, right? So here's your vertex. Well, if you look, I see a 9 and a 9. I see a 12 and a 12. 13 doesn't have a match, so 2, 13 is your vertex. What is the range? Remember, the range represents the y values. So what do your y values go to? Let's think about this. So do you notice how it's going up, up, and then it turns and goes down? So if we were to sketch this, it's actually this way. So you have the point 213 up here. So it goes up to 13, and then it keeps going into the negatives. It's going to keep going and going and going. So all of your y values are less than or equal to 13. All right. In this case, you could say that your y values also go from -2 to 13 because it doesn't show the other values and it doesn't say that it's going to continue. So you could also write it like that. Okay, because again, your y values are your range. It goes from -2 to 13. All right. A quadratic function, g of x, is shown partially in the table. The turning point of the function has the coordinates 3, -8. I'm going to circle that just like I typically do. So there's our vertex. Find the missing output values from the table. Well, since it's a quadratic function, we know that things are going to match up. So if this is -6, this is -6. If this is 0, this is 0. If this is 10, this is 10, and then this one has to be 24. Okay? What are the zeros of the function? Remember, the zeros are where it hits the x-axis, where the height, where your y value is 0. So where is the y value 0? Right here, 1 and 5. What is the y-intercept? Well, let's think about it like this. If it's hitting the y-axis, the x value is 0. Whereas where it's hitting the x-axis, the y value is 0. All right. So where is the x value 0? Right here. 10 is your y-intercept. All right. On to the next page. Consider this function. Calculate the axis of symmetry. You could use your formula, x equals -b/2a. Actually, you didn't have to do this question, but if you chose to do this question, I'll show you that here. So your a would be the number in front of x squared, which is a 1, and your b is 5. I can see this -3. It's not part of my axis of symmetry, but I know that it's going to be my y-intercept. All right, x equals -b over 2a. So -5 over 2 times 1. -5 divided by 2 is -2.5. That's your axis of symmetry. That's the line where you're going to fold it in half. So if we wanted to graph this function, you'd put it into y equals x squared plus 5x minus 3. Now, if you look at the graph, we've got our U shape, which we're used to. The problem is, if you go to second graph, we don't want to go down to these numbers because we can't graph those. Go up until you see numbers that you can actually plot. And do you see the problem? You've got everything has a match. So your turning point is usually right here between those two -9s. Well, it's not, because it's not a whole number. It's -2.5. So I'm going to graph those other points. I'm going to make a little table just so we have it right in front of us here. So, whoops. So we have -6, 3. I'm just going to copy that. -5, -3, -4, -7, -3, -9. And then I'm going to insert my axis of symmetry. I don't know what the y value is yet, but we'll talk about that. -2, -9, and everything else will match. -1, -7, 0, -3, and 1, 3. And again, when you're looking at the graph, you're going to see that it's not flat. It's going to have that nice round shape. So let's plot these points. -6, 3, -5, -3. And I do want to point out, this happens once in a while, but not often. -4, -7, -3, -9. Oops. -2, -9, -1, -7, 0, -3, which we already graphed because we knew it was our y-intercept, and 1, 3. Now, it looks like that's flat, but remember your vertex. And you might say, well, how can I figure out the y value? Well, just like anything else, if you take your x value, you can plug it into your equation. So if I look at my equation, we have x squared plus 5x minus 3. If I want to figure out the y value, I'm going to plug in my x. So it's -2.5 squared plus 5 times -2.5 minus 3. And then just type that in to your calculator on the regular screen. You can hit second mode to get there. You could type in -2.5 each time, or remember you can store -2.5 store, which is right here for x, enter, and then you can just type in x squared plus 5x minus 3. Or, like I said, you can put the -2.5 in every time you see x, but you need to make sure it's in parentheses. Either way, you get -9.25. All right, so if we graph that, -2.5 halfway, -9.25, about right there. All right, so we'll carefully, this is not going to be pretty, folks. Draw my, we'll go a little beyond and back up. Don't forget your arrows. And give your function label, since it gave it a name, f of x. We don't have to write the whole equation. We can just write f of x. And you'll see right here is your axis of symmetry. X equals -2.5. Always halfway between everything. All right, last question. A little bit more basic. Your vertex is another name for your turning point. All right, so that's down here at to negative 4. Your axis of symmetry is that line where you fold it in half. It's going to run right through your vertex. Since it's a line, it's an equation. Normally it's y equals, but since it's not hitting the y-axis, it's just x equals 2. Gotta have that x equals. Your zeros, where does it have a height of 0? Where your y values are 0, 0, and 4. And something to point out, this is always halfway in between. All right, our y-intercept's also 0. Domain, remember it's going to, those are your x's. And this thing's just going to get wider and wider and wider as you zoom out. So you're going to use all the numbers between negative infinity and infinity. Or you can just say all real numbers, or this capital R, which, wow, that looks sloppy, with the extra line. The range, on the other hand, those are your y values. Your y values drop down to negative 4. That's your minimum value. There's no max. It goes on forever that way. So all of your y's are greater than or equal to negative 4. Wow, sorry about that, guys. Sometimes I don't like Cami very much. You could also write negative 4 to infinity, but you have to use parentheses around the infinity in a bracket for negative 4. All right, end behavior, concave up. Okay, so that's it for this video. If you have any questions, stop by the math lab or send me an email. I'm happy to help anytime. Next, we're moving on to lesson 4. It's going to get a little tricky, but we got this. Have a great day.